Hello, everybody. I really hope that you got energy from that video. It was Team 82 last Pwn2Own ICS competition, executing a denial of service vulnerability against Softing Edge connector. It was one of the most exciting events in my career. I'm happy to be able to talk about it today, to share the lessons we learned from it, and how Pwn2Own competition, how it impacted ICS security in general. So Pwn2Own competition is a white hat hacking competition. Hackers around the world, security researchers, come to execute real zero-day exploits against real targets. The targets can range from home printers to electric cars. So the 0 days, as the name suggests, are the bugs that are not previously known. So you can guess that it's not the easy competition, not for newbies. The rules are very simple. Prior to competition, 2 or 3 months before, Pwn2Own will publish a list of targets. Those are the targets against which the security researchers will find bugs. During this time, a security researcher has the time to find as many bugs as they can in the targets and then present them in the physical event. For each 0 day, the security researcher will have 3 attempts. The entry can end with either success, if one of the attempts succeeded. If all of them failed, it's failure. And if the bug was used for the 0 day was already used within the competition, it will be count as a partial win. Of course, as being white hat competition, all the 0 days vulnerabilities will be disclosed to the vendors at the day of the event. Of course, the security researchers do not invest all the time only for fun, but also for profit. Pwn2Own awards each year a pretty considerable amount of money for the 0 days security researchers are discovering. Along with the cash prize, there is also a Master of Pwn title that goes along with this pretty cool trophy designed for each event. There are several types of Pwn2Own competition. Of course, we will be focusing on the Pwn2Own ICS. Pwn2Own ICS was introduced in 2020, and since then, there were 3 Pwn2Own ICS competitions. All of them were held running in S4 competition, the biggest ICS conference ever known. Those are the vendors that participate in the competition. You can see that high-profile vendors embracing such events. Products of the vendors are listed in the target list that participate in the competition. There are several types of targets that is listed in ICS Pwn2Own. For each type, there is several products that are participating. Another important thing to know that there is several types of exploits. So, for example, a security researcher that finds a denial of service vulnerability, he will get $5,000. For running a remote code, he will get 20. So what is for us? Claroty Team 82 is a vulnerability research team focusing in the OT and ICS sector. It was natural for us to test ourselves against best hackers in the world. You could say it took us a while to get there, but after 3 years of hard work and dedication, a lot of excitement, we got there. In the last Pwn2Own event, we took our trophy home, and now it sits in our lab, showing us our achievements. So it is not an easy competition. I want to show you how we did it with an example of OPC UA targets. OPC targets are clients and servers that implement OPC protocol. There is an interesting trend in Pwn2Own competition regarding the OPC targets. As you see, the number of targets that implement OPC protocol grew with years, showcasing its significance. For those who isn't familiar with this protocol, let me say just 2 words about it. Before the OPC protocol was developed, vendors used to implement their own proprietary protocols for the PLC, and the HMIs could communicate with each other. So if the engineer would like to connect one PLC with an HMI, he needed to, that both of them will be produced by the same vendor. So they both can communicate with the same language. This difficulty is what OPC come to solve. Now, when an engineer wants to connect 2 devices in its manufacturing, the only thing he needs to know is that they both implement OPC protocol. Being open, versatile, and secure, it's what it brought its popularity. So let's back to our research in Pwn2Own ICS competition. We got our listed targets, and we saw a lot of targets that implement OPC protocol, and we decided to go all in. The first thing we need to do right now is to set a setup. We obtained each of the application and installed in separate VM, and we configured each of the application with its default configuration, nothing more. The last thing to do is to deep dive into the documentation. You see, protocol is here for around some time. The low-hanging fruits are already taken. We need to find a meaningful bugs if you want to win the competition. So we need to go deep. For those who are familiar with the standards, know that it's not an easy read. It's a long documentation, and we did all of it. I would like to show you how I, a security researcher, reading such documentation. Let's take, for example, a message header and a message chunk documentation with it. So message can be divided into chunks. Somehow, when client sends the message chunks, the server have somehow to know where the last chunk is arrived. For this, there is final flag within the message header that says that, hey, I'm the final chunk. You can start to construct a message. There is the question that I, as a security researcher, would ask myself, what if that flag will never arrive? Will the server just wait forever? What will happen if thousands of such messages will arrive? You got the idea, I hope. Next for us will be to build our own client. There is a lot of OPC client out there, but we needed one that we can fully control the payload we send. We want to tweak the protocol so we can test the implementation of the server and find bugs, of course. There is 2 main types of bugs that we are after. The first one are logical ones. This way, we use the documentation we read and our client, and we just try in the same way we talked about it before with its final flag and see what happens. Another type of bugs that we are after, of course, are memory corruptions. For memory corruptions, we use fuzzing. Fuzzing is a technique in a way that random input is fed into application in a goal to cause a crash. When a program crashes while parsing some payload, it means that there is some way, more often than not, some type of memory corruptions. We used coverage fuzzing, like AFL, and it did find bugs that were exploited. But in addition, we used a network fuzzing. A network fuzzing is a little bit longer to develop, but it is a great way to fuzz some complicated protocols like OPC-UA, because some fields have to be stay input in order to get to the real logic. We used our OPC-UA protocols, OPC-UA network father for all of the servers. And we did find bugs. And one of them were exploited to remote code execution. And this is how it looks like. This is really exciting moment for a researcher. It is what we see here is network fathers are sending its payload, and one of them is crashing the application. You could say that this research was a success. Those are vulnerabilities that was found on OPC-UA targets only in Pwn2Own competition. This has greatly contributed to our win. Now that we saw how we approach such type of research, I would like to talk about attack scenarios. This is a key lesson we learned from being competing for 3 years in a row. The entry points a hacker uses, hackers or security researchers, attackers, that can use in order to hack an application. The first attack scenario that I would like to talk about is malicious project file import. This scenario is very simple. An attacker finds a bug within an application, and then he tries to somehow provide the project file he built to the innocent victim. The innocent victim opens the project file, and the next thing he sees, he's been hacked. There's various vulnerabilities that can be triggered during this attack scenario. I would like to show you an example of path reversal, how path reversal vulnerability can lead to remote code execution. Let's think about it. How would you implement import of the project file? Of course, first, you need to extract the data. Therefore, you need to build databases, to create objects, to put the images in its places, and so on. Let's focus on the extraction data. For example, in our very simplified example, we have our project file and we have the files packed in that project file. We have our databases, some DLLs, metadata, you name it. The extraction procedure is very simple in this simplified scenario, of course. We just extract this data to some destination directory. The question arises, what if the application allows path reversal directives in file names? If this is the case, an attacker just can rename the driver DLL to be with path reversal directive that will escape the directory and will overwrite some DLL of another popular application. In such case, when the poor innocent victim will open that application, a code of the victim will run. Those are vulnerabilities that were executed in Pwn2Own competition and caused a remote code execution that used path reversal vulnerability. So you could say this is a quite popular one. Another attack scenario is a natural one, is network malicious payload. In this scenario, we have our application that listens to some known port, and we have an attacker that have a bug. And now we want to trigger it by sending some exploit and compromise the application. Here, like the last time, there is multiple vulnerability types that can be exploited. I would like to take an example of resource exhaustion. Let's, again, a very simplified example. Let's imagine this situation. We have a really simple protocol, like data size followed by data. That's it. Okay? And we have our server that will parse the data. He will receive the payload, he will extract the size of the data, and then will allocate memory for the data so that it can work with it. What will happen if the server will not validate the size that he parses from the data? He will just allocate the amount of memory that it gotten from the user. In such case, it can be exploited to denial of service condition. At some point, the RAM memory will just end. Those are vulnerabilities in Pwn2Own ICS competition that used resource exhaustion situation and caused denial of service. So how Pwn2Own ICS impacted the ICS industry? The very important thing that I would like to talk to you about is a number of bugs, real 0 days, that were patched and remediated in high-profile applications. Those are not some simple bugs. Those are real 0 days that cause denial of servers and code execution. And they all have been patched thanks to the competition. Another great thing that happened is a response from the vendors, how they responded to such competition. They embraced the fact that security researchers are searching for vulnerabilities, that it enables them to patch and fix them. Another very important thing that happened is the amount of knowledge that is now available to the community. Right now, for a newcomer to come and research ICS products, it's much easier than it was prior to Pwn2Own competition. So what's next? We cannot not to talk about it. There is no Pwn2Own right now. We are at S4. Pwn2Own was held near with S4 like for 3 years in a row. What happened? You see, there is a real challenges that prevented from Pwn2Own to exist this year and the year before. Bringing the variety, the good variety of targets to the competition is really hard. There were no PLC or field devices in the competition, and just it had been too hard to keep the target list versatile. Another thing is that the vendor, although there are vendors that do embrace the competition, it's still not alive. It's still not enough to keep the competition alive. I would like to sum up this talk with some words. The bad guys are always there, and they have all the resources, time, and money to exploit those 0 days. It's there. It's not going anywhere. But competitions like Pwn2Own and bug bounty programs are the way for white-hat hackers and security researchers to find those 0 days and bring it to be remediated and patched. So if you are a vendor, I encourage you to participate in those competitions, to bring your products so the security researchers can find bugs in them. And if you are a security researcher, I really encourage you to participate in such programs like Pwn2Own competition. Thank you very much. I'm here to answer questions.
Hi, Vera. Thank you for your comments. When approaching large software products, how does your team prioritize which areas to fuzz?
How do I prioritize? It's a great question, because in such competitions, we have a really limited time to hack those devices. And it's like an intuition of a security researcher that need to somehow to know what bug will lead him to denial of service or remote code execution. I would say it just takes a lot of experience, and it is really important to know how easy it was to find a bug. Because as you remember, I said that if the bug was already known, in the competition was already used, so it will be a partial win. So the harder the bugs to find, will be our best shot. And it takes a lot of experience and a lot of work, I guess, I would say.
Thank you.
Hi, Vera. Thanks for coming up here. I'm Nathan Boger from Inductive Automation. We really appreciate you and Team 82 for what you found throughout the years. I guess my question is, we've been actively reaching out to ZDI. I guess I haven't this year yet, but I'm just wondering if you and if there's just other folks that are reaching out to them, letting them know that it's valued. Since we've gone 2 years without the ICS Pwn2Own. I guess my question is just for you and the larger group, if there's more things that we can do to try to get it back.
For the competition?
For the competition, right? Since it's been discontinued for the last couple of years.
I hope that it will get back somehow, but we cannot not know.
Yeah, I guess it's just a point to the larger group here.
Yeah. So as I mentioned before, I really hope that if the importance of such competition will be known and understood, be much easier for Pwn2Own to bring back the ICS category. Because if the vendors will be willing to participate, the hackers, the security researchers are very eager to find bugs.
Sure.
Just give them a target and they will be on it. The real problem is the participation of vendors, and of course, as I said, the challenge of bringing ICS field equipment to the competition, which is really hard because there is no place to connect oil detector or something.
Sure. Thank you very much.
Hi, thank you for your presentation. I have a question. When you are developing network fuzzers, how do you deal with the challenge of finding out if the process crashed because it received too many packets or because it actually received a malformed packet?
I'm sorry, about the fuzzers?
Yeah, with network fuzzers, sometimes when you are developing network fuzzers, it happens that it crashes because the process received and had to process so many packets, and it crashed because of that and not because the packet was malformed. So how do you deal to identify which ones are actually because of a malformed packet?
Yeah, so I will answer you about the network fuzzer because I was the one who developed it. So in network fuzzer, we took the protocol and we fuzzed only specific part of it because there is a lot of validations. So in this type of fuzzing, there is not a lot of crashes that you need to somehow to triage them. If at some point there is a payload that will crash a device, you know for sure that you have something here. It's not, it can be some randomly taken. Of course, we validate it again, but if it's reoccurs, it's for sure the real bug that we can use, at least for denial of service. In the specific scenario of our fuzzer that in the bug that we have found, it was later developed to remote code execution, which is really cool. But at least you have the denial of service.
Thank you.
Hi, Vera. Thanks. Great presentation. I just had a question about the in-memory fuzzing. Did you have to make any customizations to the target in order to run things like the AFL or other in-memory fuzzers?
Can you just come more close to the microphone?
Sorry.
I didn't hear you. Thanks. Sorry.
Sorry. Thanks. Great presentation. I just had a question about the in-memory fuzzing. So for things like AFL fuzzing, did you have to make customizations to the targets in order to have those execute? Can you talk a little bit about the, I guess, test harness for the in-memory fuzzing approach?
About targeting our customers, yeah. So this is a great question. There indeed was some issues. Firstly, it's what our team doing. It's our job to find vulnerabilities and disclose them. In the case of Pwn2Own competition, it's very similar to our everyday job. It's not that it is publicly disclosed that the bug was found, but in the end of the day, the customer products are more secured. So that's a win-win for everyone.
Okay, thank you.